9.1, 9.2, quadratic functions. We're going to be talking about their graphs and their properties, and we're going to the vertex, the axis of symmetry, and graphing these parabolas. These are going to be used in those things we learned when we were factoring, those factors. We're going to be using those to graph these. We won't be working with lines this time. Now we're going to be working with things that have a curve. I want to give a shout out to my 8th block Algebra 1 class of 2013-2014. I love you guys. You are really bright students. I can't wait to see what you do in the future. Alright, so some of the key vocabulary you're going to need to know for this section is quadratic function. Everything in this section that has to do with a parabola of the highest degree of 2, so I'll put on here degree of 2, is a quadratic. They will be functions. They will be non-linear, which is a term you'll be using a lot next year in geometry. But non-linear, well, we know what linear means. Linear means it has a line, okay? So non-linear means it's not a line. So these are going to have curves. So it won't be a straight line ever in quadratics. They are functions, and they follow the form of f of x, the function of x, is equal to ax squared plus bx plus c. This is the standard form for a quadratic function. We also know f of x to mean y equals. Alright? Parabola is what we call this shape right here. It's all about the shape. It's nothing more than just naming the shape. Okay? It could be a happy face like this one, or a frowny face like this one, depending on what's going on with your quadratic term. Okay? But it's just the shape. Now, the shape of the graph has the endpoints that go on forever, just like our line did. We will also have points right here at the very, very highest point and at the very, very lowest point of the parabolas. Those are going to be called the vertex. The vertex is going to be an ordered pair of x and y. Okay, and also down here, x and y. So you'll be able to locate the vertex. Again, it's the highest and lowest point. Now, if it's the highest point, that is called a maximum. Okay, if it's the lowest point, it's a minimum. And we actually use these a lot in the business world because when we're trying to decide how many products to make of something, we want to make them have the highest profit with the lowest cost. So we use these a lot when we're making things. In the business world, you know, they have to come up with these formulas in order to make the most money for the least amount of time and cost. Okay? If you didn't have those things, you would probably not make money if you were a business person. So it's very important that you understand what these things do. All right? The axis of symmetry, I'm going to draw another parabola over here. The axis of symmetry is an imaginary line, okay, you'll see it as dotted, that cuts the parabola into two equal parts, and it goes through the vertex. Okay, so the symmetry means, like if this was 2 points away on your graph, over here, this would be 2 points away on your graph. It's exactly the same on both sides. That helps you to understand how to graph these on your own on your graphing paper or using your calculator. The axis of symmetry has a specific formula, and that is this one right here. That's x equals opposite of b divided by 2a. Say the opposite of b because sometimes b is going to be positive, sometimes b is going to be negative in our standard form, but you're going to always do the opposite of that and then divide by 2 times a. All right? Very important that you read this correctly, and it will keep you from having issues with opposite and negative numbers, double negative numbers, keep you straight on those. You will need to know this, as they don't specifically give you the vertex formula on your formula sheet, but I can show you it's there, but in a different kind of formula. I'll show you in class. All right, the y-intercept is still where your parabola crosses your y-axis. Okay? Parabola will only cross the y-axis in one place. Okay? and that'll be an ordered pair also. Your x-intercepts, however, could be 1, could be 2, or could be none. Okay, but the x-intercepts are where it crosses the x-axis. All right, this case I drew in 2 because it crossed my x-axis twice. And we're going to find out that they have special names. Other than the x-intercept, they're also called roots, solutions, or zeros. They all four mean the same thing. So when we are talking about this, they may ask you this way or this way. I'm going to throw those words at you every which way because I need you to make sure you understand that they are all the same thing. The domain are going to be your x values, and that would be any of your x's run along the x-axis. And your range is going to be all your values that run along your y-axis. Okay? So remember before when we talked about domain and range, we just had ordered pairs like this. Okay, where our domain was your x-coordinates, which would be 1 and 3 in this case. And our range would be, sorry, writing awfully sloppy. Range would be 2 and 4 in this case. Well, we're going to be talking about them, but you're not going to have ordered pairs like this. You're going to be talking about a much bigger range of numbers. Okay, so you won't be writing like this. You'll be talking about bigger ranges of numbers. All right, let's look at some pictures. All right, so when you're talking about this now, we will not have two parabolas on one graph ever, but I wanted to show you both the parabolas on one to save some time. Notice the dotted lines going through here. That's your axis of symmetry. And again, they are imaginary lines. They will run through the vertex and split this exactly into two pieces. All right, that's what it does. Your vertex is going to be the point at the either highest point or the lowest point. If it's the highest point, it's the maximum. If it's the lowest point, it's the minimum. Your y-intercepts are the point where it crosses the y-axis, right here and right here for each one of these. And then you're going to have your x-intercepts that we'll talk about coming up. All right, so this is just a picture of the graphs. And again, that axis of symmetry will not be in your pictures. All right, so let's get going on this. All right, so we're going to graph the first example, and that's f of x is equal to x squared plus 8x plus 9. This is our function that we will be graphing. We have to start with the vertex. Always start with that. So what you want to do, I think black will be all right. All right, your quadratic term, your linear term, and your constant, they need to be in descending order. Remember, descending means going down in this format in order for you to find out what your A, B, and C are most of the time correctly. I've seen students where it wasn't in the right order and then they wrote the things wrong. So make sure it's in descending order. X squared, x to the 1 power, and then no x, okay? When you do this, I'm going to label over top of my stuff. This is my A coordinate, or my A term. This is my B term, and this is my C. All right, so I'm going to want you on your paper to write A is equal to, B is equal to, C is equal to, and write down what you have. My coefficients is all we're talking about. There will be no x's over here, just numbers. So my coefficient of my x squared term is just 1, so that's going to be what A is equal to, 1. My coefficient of my linear term is 8, so I'm going to put 8. And my coefficient of my constant term is 9. There should be no letters over here, no x's or anything, just your numbers. All right, then you're going to put these numbers into your formula, which we talked about on the other side. I'll write it up here. Opposite of B divided by 2 times A, that's x equals. All right, so we need to find the vertex, and we're going to find it by first finding the x-coordinate of the vertex. So I'm going to plug in information right here. Now, you'll notice right away I don't have C in my problem. We'll use C a couple sections down the road. So just separate it and just get into the habit of doing it. But right now we're just going to work with A and B. So I'm going to say, what is the opposite of B? Well, my B right now is 8. So the opposite of B would be a negative 8. And then it's 2 times, okay, 2 times A, my A is 1. All right, so you just do your math. It's negative 8 over 2 times 1, which is 2, and you need to simplify that. That will be negative 4. That's my x-coordinate, okay? So you will put negative 4 right here. Now, how do I find the y-coordinate? Well, if x is negative 4, I can go back, I'm going to write over here on the side, and plug that into my original equation. So I'm going to say, and you need to use parentheses, negative 4 squared plus 8 times negative 4 plus 9. And compute that. That's going to be negative 4 squared is 16 plus, whoops, let's not do plus. We don't do that. All right, 16 minus 32 plus 9. And remember, order of operations says you have to go left to right in order. So 16 minus 32 plus 9, if you put all that in your calculator, will give you negative 7. And that's where the y-coordinate comes from. So you have to find the x-coordinate first, plug it into your original problem using parentheses, and then compute to get your y. That is your vertex. At that moment, you can go and plot that point. So come down here at negative 4 and negative 7, and there's my point right there. This is my vertex. Now, because it has a positive x squared term, this is going to be the shape that you will always have if it is positive. So if your x squared is positive, it will always be happy. Happy people are very positive. Okay? So we will always, if we have a happy person, have a minimum. Okay? Think of it like this. Happy people have minimum sad days. Happy people have minimum sad days. Alright, so when we do this, we will have a minimum there. Our axis of symmetry, we already found x is equal to negative 4. Alright, so we put that point there. Okay, and then what we do is we can find, let me clear off some of this stuff. Well, it's right over here. We can find our y-intercept very easily. Y-intercept. Let me write that over here. To find the y-intercept, plug in 0 for x. Okay, if you plug in 0 into your equation, y is equal to x squared plus 8 times something plus 9. Okay. Plug a 0 in there and there, y will always be whatever your constant is. Okay, so when you plug a 0 in for all of these, you're always going to get whatever your constant is as your y-intercept. So that is 0, 9. Remember, it has to be ordered pair, and the y part is the back. Alright, so then we've got the y-intercept, and we've plotted that. We've got our vertex, and now we need to find some values. Okay, so you're going to write this in a table, your formula, your equation, excuse me, an x column and a y column. It's the same thing as a y. If I plugged in a 3 into every x, this would come out as a negative 6. So my order pair would be negative 3, negative 6. If I plugged in a negative 4 into every x, then I would come out as a y would be negative 7. If I plugged a negative 5 in, I would end up with a negative 6. So negative 3, negative 6, negative 4, negative 7, negative 5, negative 6 are all points that you can put in your graph and plot, and then draw your parabola through it. Okay? Now, a lot of times you may want to choose smaller numbers. You'll see us use 0, 1, and 2, and also negative 1, negative 2. Okay, those are smaller numbers where you can possibly fit the graph on your graph paper a little bit easier. Okay, so you just pick some numbers. It doesn't matter. I suggest smaller the better on your X. Plug them in and see where they use parentheses. It's going to be imperative that you've got to use this because we're working with squares, and if you don't do it correctly, you're going to get the wrong answer if you don't use parentheses. All right, and then plug that in into your calculator. You can type it in just like you see it right here, and you'll get negative 6. Okay, those are the ways you find your other order pairs. Now, let's talk about the domain and range. Domain on these parabolas, okay, you'll notice how this side is going on and on and on and on and on and on and on forever this way. As it's doing so, it's getting bigger and bigger and bigger and bigger. Now, this is only a two-dimensional small window of numbers on your x-axis. But if we were able to, and there's no way we could, spread this out so you could see what happens over the course of this thing getting bigger and bigger and bigger, it will incorporate all the x values on this number line in this direction. Same thing with this side. It gets bigger and bigger and bigger and gets fatter and fatter and fatter, and it will go on and on and on this direction also. Okay, towards negative infinity over on this end on the x-axis, and towards positive infinity on this end on your axis. Because it does this, no matter what is going on, any parabola, okay, as far as the domain, will always have all real numbers. It will incorporate all the numbers this way and all the numbers this way. Sometimes you'll see real written like this, with this double barred R. That means real. That means it's going to cover all these and all these. And sometimes you'll see me write negative infinity to positive infinity. That means it also goes and covers all those numbers. Okay, and that's what the domain does as far as the x's are concerned. It will cover all of them. Okay, let me erase some. I've got the biggest mess on here. All right, now if we were talking about the range can be very specific on parabolas. Whereas the domain for any parabola, whether it's upside down or not, is going to be all reals all the time. The range will change. Okay, you have to find your lowest point on your graph. Okay, and my lowest point on my graph is right here at y negative 7. Okay, that is my lowest point. That could be anywhere because your graph's going to be all over the place as far as on the y-axis. So you look for the lowest y, okay? And then you look and see, is it going up or is it going down? If it's going up, that would be a greater than or equal to. If it was going down, it would be a less than or equal to. So that would mean all the numbers on the y-axis from negative 7 all the way up towards positive infinity on the y. Okay, so this is going to be all numbers greater than or equal to negative 7 on my y's, which is your range. Okay, so we will go back and forth with these, but the domains on parabolas are going to be all real numbers. The range, however, is going to be limited. Okay, let's look at another one. All right, this one is g of x, same thing as f of x, it's still y equals. But notice this is a negative x squared. Anytime you have a negative x squared, you're going to have an upside down, sad, negative parabola. Okay? So it's sad negative parabola. You will still compute the axis of symmetry and everything the same. Okay, so let's go ahead and do this. This would be A, this would be B, and this would be C because it is in descending order. And I would expect you to write A, B, and C over to the side and exactly what you have. Then you will plug that into your formula for axis of symmetry. Opposite of B divided by 2A, 2 times A. For this one will be opposite of B. Well, B is positive 4, so the opposite of that would be a negative 4 divided by 2 times A is negative 1. Alright, do your calculations. That's going to be a negative 4 over a negative 2. So X is going to be 2. A negative divided by a negative is a positive. Now, to find your Y coordinate, you plug it into your original problem. That's going to be negative parenthesis squared plus 4 parenthesis minus 1. Alright, so when you're doing this, what's being squared is the x, not negative x. Okay, so you plug this in. There's a 2, there's a 2. So that's going to be 2 squared, which is 4. 4 times a negative 1 is going to be negative 4. Plus 8 times 2 is, 4 times 2 is 8 minus 1. So that's going to be a negative 4 plus 8. Remember, you have to go left to right. Negative 4 plus 8 is 4. 4 minus 1 is 3. Alright, so be very careful. That negative in the front is not what's being raised to the second power. That's why you must use parentheses. Otherwise, it's going to give you the wrong answer. Alright, so now we have our x and our y coordinate. That's our vertex, and we can go ahead and plot that point. Again, to find the y-intercept, plug in 0, and you will get your y-intercept at 0, negative 1. That's point right there. Okay, so now you got 2 points on there. You're going to need to have 3 or 4 points in order to graph a parabola. So you can't just stop with 2, because any 2 points will just make a line. We have to have at least 3 or more to make a parabola. Alright, so we are going to now plug in some points into our table. Okay, and we're going to plug these in and find out what we got. Again, making sure you use parentheses, right? So when I plug in 1 into my formula, I get 2 for my y. So my order pair is 1, 2. When I plug in a 2, my order pair becomes 2, 3. When I plug in a 3, my order pair becomes 3, 2. These are points that you can go ahead and graph. So at 1, 2, 2, 3, which was my vertex, and 3, 2 are the points that are on here. Again, y-intercept, this is going to be an x-intercept, this will be an x-intercept, and these are your other points. Now, when we're talking about this, again, looking at your graph, your domain is going to be all reals, because all parabolas have the domain of all reals. But for the range, you look for the lowest y, or the highest y in this case, where it starts, because it goes from there and goes on down. Alright, so then this would be at 3, and because it's going upside down, that would mean y is less than or equal to 3. All the numbers below 3 on the y-axis will be included in your range. Okay? Alright, now, as far as these zeros and solutions, we're going to be working with the calculator and locating those. Let me show you what I'm talking about. Alright, so you're going to be going to y equals, and you're going to be typing in these functions. So I'm going to type negative x squared plus 4x minus 1. Okay, there you go. There's your function. You're going to be graphing it. Okay, and then we're going to be finding where it crosses the x-axis, specifically that point right there and that point right there. we're going to be using the second trace option again. We're going to be looking for zeros. So you go ahead and push a 2. And we're going to be talking about left and right bound. Now, it goes and follows this parabola in order, like it goes this direction. Now, if it was an upside down U, it would go this direction. So just follow from left to right. So we're going to have a left bound and a right bound. What that is doing is it's trying to minimize the area that it's looking for, the 0. So we're going to go on this side of the x-axis, then that side of the x-axis, and then it's going to ask you for a guess. So I'm going to hit enter. I'm going to move him up a little bit, little spider guy, hit enter. So it's between those 2 points, and then hit enter. So this is telling me that my 0 is at 0.267 blah blah. I'm going to let you round it to 0.27. Yeah, sometimes we will have decimals when we're talking about these. You won't be converting those to fractions, okay? These will be on your calculator as decimals. Alright, so that's the 1 0 right there, 0.27. Now, I need to do the 1 over here. So I'm going to hit second, and I'm going to hit trace, and I need to find the 0. I'm going to move the spider guy. Alright, again, we're going left to right, so I have to do above and below this time. Enter, and I'm going to go below the x-axis, and hit enter, and hit enter again. And it's going to tell me that this 0 is at 3.7 whatever, and the order pair is 3.7, comma 0. So that is my other 0. Okay? So we will be locating these with our calculators. Also, again, you would hit the second, trace, 0, which is 2. Okay? And then you're going to do left bound, right bound, and a guess. Okay? We'll be practicing with these too. Alright, let's see, do I have anything else on this one? Nope. Alright, so we will be practicing with these. Come see me if you have any questions, and I'll see you in class.